Welcome back to our video course. By the end of this module, you will be able to use the terms AI, machine learning, deep learning, and data science with total precision and spot exactly when others use them too loosely. In our last video, we opened the hood on how systems shift from following handwritten rules to learning from data. Now we use that foundation to untangle these 4 key terms. We have 5 parts ahead, covering each of these concepts. In this first part, we will establish the big picture. I will share one essential diagram to keep in your mind for the rest of this video, which shows how these 4 concepts are actually related. Why do these terms get confused so often? It's because they are nested categories. Think of it like the difference between the word vehicle and the specific term electric car. Mixing them up is common, but imprecise. This diagram is our roadmap. AI is the broadest category, containing machine learning, which in turn contains deep learning. Data science sits alongside these, often using them as tools, but also encompassing its own distinct work. To read this diagram, remember 2 rules. First, nested means one is a type of the other. Second, overlapping means they often use one another. Keep this structure in mind as we dive deeper. Let's apply these lenses to Netflix. AI is the goal of keeping you engaged. Machine learning is the recommendation engine finding your patterns. Deep learning powers the nuanced behavior analysis, and data science designs the experiments. Now let's explore artificial intelligence. This is the broadest term in our model, and it is frequently used in very loose ways. Let's make it precise. At its core, AI is any technique that allows a machine to perform tasks typically requiring human intelligence. The key word here is technique. It is not one specific technology, but a field of methods. A common mistake is assuming I must involve learning. It doesn't. Systems like the medical tool MyCN or classic chess engines were built with handwritten rules, yet they remain valid examples of AI. We must also distinguish between narrow AI and general AI. Narrow AI is built for specific tasks and is what exists today. General AI is purely hypothetical. Every system we discuss in this video is narrow AI. Here are a few examples of how AI appears today. They span from simple, rule-based systems for route planning all the way to complex, deep learning-based chatbots. Next, let's look at machine learning. This is the data-driven subset of AI that dominates the conversation today. Machine learning involves systems that improve by learning from data, rather than following rigid, hand-coded rules. This is that paradigm shift we discussed in our previous video. The dividing line is whether the system learns from data or uses fixed logic. Here, you can see clear examples of AI that does not use machine learning, compared to those that do. So what defines machine learning? It relies on 3 core criteria. Use this as a checklist for any system you encounter. First, it requires data to learn from. Second, it improves its performance over time without needing to be manually reprogrammed. Third, it can generalize those learned patterns to handle entirely new, unseen examples. These are common everyday examples of machine learning. Spam filters learn from flagged emails. Recommendation systems learn from your history. Fraud detection identifies suspicious patterns, and predictive text learns your common habits. They all improve as they ingest more data, without a human needing to rewrite their rules. In short, machine learning is behind nearly every online recommendation you see. It is always improving as more data accumulates, unlike traditional static software. And it is no longer just for tech companies. It is now powering advancements in healthcare, finance, agriculture, and logistics. Moving on to Part 4, Deep Learning. This is the subset of machine learning that has driven the most significant AI breakthroughs over the last decade. Let's cut through the hype and look at the precision behind the term. What is deep learning, really? It is a subset of machine learning that uses artificial neural networks with many stacked layers, which is exactly where the name deep comes from. While we will cover the mechanics in Module 6, for now, just remember that every deep learning system is machine learning, but not all machine learning is deep learning. It is important to remember that not all machine learning is deep. Many effective, everyday tools rely on simpler, shallow methods like decision trees or linear regression. These are still machine learning, but they don't involve the complex, multi-layered networks that characterize deep learning applications like ChatGPT or face recognition. Why do we call it deep? Imagine an assembly line. Each layer processes information and refines it before passing it on. In vision, the first layer might see edges, the second shapes, and later layers complex objects. Stacking these simple layers is what allows deep learning to capture incredibly complex patterns. Deep learning unlocked the capabilities we see today. The 2012 ImageNet milestone and the 2017 Transformer paper are the direct reasons for today's AI boom. Tasks like human-level image recognition and natural language generation were things that classical, non-deep machine learning struggled to perform reliably. Here are some core examples of deep learning at work: image recognition, large language models, real-time translation, and advanced voice synthesis. All of these share the foundation of deep neural networks being trained on massive, high-dimensional datasets. Let's recap the nesting. Artificial intelligence is the broad goal. Machine learning is the subset that learns from data. Deep learning is the further subset using multi-layered networks. Understanding this hierarchy helps you see exactly where each term fits. Finally, we reach Part 5, Data Science and Generative AI. We are adding two more essential pieces to our puzzle. Let's see how they connect to the rest of the field. Data science is an interdisciplinary field that combines statistics, programming, and subject matter expertise to extract value from data. Importantly, it is broader than AI. Data scientists often perform critical work, like cleaning data or building dashboards, that has absolutely nothing to do with machine learning models. To distinguish the two, data science is the full pipeline, from asking the right business question to communicating insights. Machine learning is a specific technique for building systems that learn. A data scientist might manage an entire project without ever building an ML model, and that remains legitimate data science. Lastly, we have generative AI. This is a category of models capable of creating entirely new content, like text, images, or audio, rather than just classifying data. ChatGPT, Claude, and DALL-E are the most visible examples, representing the newest member of this technological family. So where does generative AI live? It sits squarely within the realm of deep learning. It is a powerful application of these advanced models, bringing us to the cutting edge of what is possible today. Keep this full picture in mind as you navigate the world of AI. Let's bring it all together. Our diagram shows the full picture: AI as the broad boundary, with machine learning as the data-driven core, and deep learning as the advanced engine for modern breakthroughs. Data science rounds it out as a wider discipline that uses these tools while also standing on its own. It's time to bust some common myths. First, that AI always means a robot or chatbot. In reality, it's often invisible, like a spam filter. Second, that AI always learns. Many systems are just rigid, hand-coded rules. And third, that AI and machine learning are the same. ML is just one, albeit dominant, approach. Let's debunk a few more. Deep learning isn't just a fancy synonym for ML. It's a specific, multi-layered technique. Also, being a data scientist isn't strictly the same as being an ML engineer, as much of their work involves pure analysis. And finally, generative AI is predicting patterns, not genuinely understanding meaning. Now test your knowledge. Look at these 4 examples: a rule-based GPS, a learning spam filter, ChatGPT, and a dashboard building analyst. Pause the video here and guess which category each falls into. Are they AI, ML, or something else? Let's check your answers. The GPS uses fixed rules, so it's AI only. The spam filter learns from data, making it AI and ML. ChatGPT uses neural networks for generation, covering all 3, AI, ML, and DL. Finally, the analyst building dashboards is doing data science, which may not involve any ML or AI at all. Use this vocabulary table as your go-to reference. Feel free to pause and screenshot this slide, as having these definitions clear will serve you well whenever you encounter the buzzwords we've discussed today. To recap our main takeaways, these terms are nested, not synonyms. AI doesn't always imply learning. Data science is broader than just building models, and generative AI is a high-powered subset of deep learning. Using this language correctly gives you a serious edge in understanding the field. You've mastered the definitions, and now it's time to see the gears in action. In our next video, we'll dive into the fundamental ways machines learn, exploring the differences between supervised, unsupervised, and reinforcement learning. Great work making it through this module. You now have the vocabulary to speak confidently about AI. I'll see you in Module 5, where we start getting into the mechanics of how these systems actually learn.